real-time systems or real-time operating systems is a kind of term that you might have heard during your undergraduate operating systems course, okay? But never really these things are explored at length, okay? The reason being, like, it becomes really complex and the time period also is not really suitable for these kind of discussions in the undergraduate courses. So this series aims to be that kind of a bridge, okay, that will give you an industry insight of how real-time systems or real-time operating systems work. So today this field is highly evolving, free from AI, okay, that's the important part, because this kind of system have critical constraints where many parameters are involved, even like human life parameters, like health parameters also involved. So many of the systems are devoid of any use of AI as of now, okay? In the future we might not be able to guarantee that AI might seep in or not. So these are the kind of systems that are developed for specific purpose. So what could be that specific purpose? So these purposes ranges from things like aerospace, defense, then medical equipments or that sort of a thing. So these are specific operating systems, or you could say embedded systems. And in many cases these are like highly evolved systems as well. It is not like you could say it is like limited to like embedded systems with low memory or that sort of a thing. So like full-fledged systems with functional MMUs and stuff also house real-time operating systems. So the use case of where operating system, this real-time operating system might be needed is very huge, okay? So a lot of applications are there. So to give you a gist of how this thing differs from our general purpose operating system. So in general purpose operating system, most of our code or most of our operations are based on user input or whatever user decides to do. So he has a GUI. So if you have your Windows system, on one window you can open your Excel, PowerPoint or that sort of a thing. And in the browser you can have like 4 different tabs running, not even 4, like you could have 400 tabs running. So everything is based on users input, okay? But on the other hand, when we speak of real-time systems, so user input does play a role. It's not like there's no user input as such, but the kind of operation and the input, that always remains the same, okay? So if you are getting a sensors data, so like if you have like 4 to 8 different sensors whose data is being read, and based on that some operation is being performed. So you could say if you are building a, what you call a simple, what you call a drone or something, so that drone will always be having like something called as an accelerometer, IMU and all this kind of sensors, and that sensors input would always be the same thing, okay? So different set of inputs will not be there, like same set of inputs, only the values are changing. But whereas on a general purpose operating system, you are free to do anything you want, okay? There are cases when it could get hanged or something, but in RTOS you have something called a soft real-time system and one is the hard real-time system. In hard real-time systems you have like very harsh constraints. Very harsh constraints is like very hard timelines, you could say. So like if something has to be executed in a millisecond, then it has to be executed in a millisecond. So it cannot take a longer, like it could not take 5 milliseconds or 4 milliseconds. The timing variation should always remain the same, okay? So this is basically being called deterministic. So determinism ensures that the worst case execution time remains the same, okay? So if something at its worst case requires 10 milliseconds, it will always require 10 milliseconds and not 15 milliseconds or that sort of a thing. So how does this thing is ensured? So like I said, the program or the set of programs that are running are usually the same. So like it's not like now you're opening PowerPoint, after some time some other application is opening or that sort of thing is there. So orchestration level only you have like sorted out the things. So like it is always the same program that is running, okay? That is one part. Secondly, regarding the timing that I told you about, so that is done by making things less dynamic, okay, and more static. So what I mean by less dynamic and more static, so there are no dynamic allocations, okay? Most of the real-time operating systems prefer to use data structures that are static in nature. So you do not have or preferably do not have data structures that are dynamic. So using things like vectors or any kind of collections framework, that would go against the grain. Okay, so these are the kind of systems that we'll be designing. So for this specific what you call tutorial, okay, like this series or that sort of a thing, so we'll be using STM32 series microcontroller, that is the Cortex M4 base STM32F303. So this will be a discovery board that I already have, and on that we will be seeing how we can build a real-time kernel. Okay, so it has an internal timer that will give us the ticks, and we can arrange things. So it does not have a functional MMU or the memory management unit, but it does have something called as memory protection unit. Okay, so what exactly is to be done and whatever is needed, we'll see alongside when we actually get into this, the actual course. Okay, for now this was just an introduction to this kind of course. Hopefully this will be helpful to people. Thank you.